Welcome to our animated guide on computer architecture and organization. Ever wondered what's going on inside that sleek laptop or that powerful gaming rig? It's not magic, but it's pretty close. Today, we'll break down some key concepts to help you understand how computers work. We're going deep into the world of bits and bytes, exploring the fundamental building blocks that make our digital lives possible. Get ready to have your mind blown as we demystify the complex and fascinating world of computer architecture and organization. Imagine a computer as a well-organized city. Computer architecture is like the city's blueprint, defining its overall structure and how different parts interact. It's about the big picture, the design of the CPU, memory, input, output devices, and how they connect. We're talking about the roads, bridges, and tunnels of the computer world, enabling smooth data flow and processing. Think of it like this. You wouldn't start building a city without a plan, right? Similarly, computer architecture lays the foundation for how software and hardware work together seamlessly. It's the grand scheme that dictates how instructions are processed, data is stored, and ultimately, how your computer functions as a whole. Now let's zoom in on the details. If computer architecture is the blueprint, then computer organization is how we bring that blueprint to life. It's about the actual physical components, the buildings and infrastructure, and how they're connected and arranged within the city. We're talking about the nitty-gritty details of the control unit, arithmetic logic unit, registers, and the flow of information between them. This is where things get really interesting. We're diving into the clock cycles, the instruction fetch, decode, execute cycle, and how data moves through the system like traffic, flowing through a well-coordinated network of streets. Understanding computer organization is like knowing the city's traffic patterns. It helps you understand how everything works together efficiently. So, we've got architecture, the blueprint, and organization, the implementation. They're closely related but distinct concepts. Think of it this way. You can have multiple cities with different layouts and designs, but they can still use similar building materials and traffic systems. Similarly, different computer architectures like x86 and ARM can have different design philosophies, but they still share common organizational elements like ALUs and control units. It's like comparing a modern city with a historical one. Different styles, but both designed to function as cities. Understanding the nuances between these two concepts is key to grasping the bigger picture of computer systems. Let's meet the key players inside a computer, the functional units that do the heavy lifting. First up, we have the ALU, the arithmetic logic unit, the math whiz that handles all the calculations and logical operations. Think of it as the city's financial district, crunching numbers and making decisions. Then there's the control unit, the brain of the operation, fetching instructions, decoding them, and directing the other units to execute them. It's like the city council, making sure everything runs smoothly and efficiently. And of course, we have the memory unit, storing data and instructions, acting as the city's vast library and archives. Just like a city needs efficient transportation, a computer relies on buses to move data around. These aren't your typical buses, though. We're talking about electrical pathways that carry bits of information between different components. We've got the data bus, the information superhighway, carrying data to and from the CPU. Then there's the address bus, which acts like a GPS system, specifying the memory location for data access. And finally, the control bus, the traffic controller, carrying signals that regulate data flow and operations. Imagine having small, super-fast storage units within the CPU itself. That's what registers are. They're like the CPU's personal scratchpad, holding the data and instructions that are actively being processed. Think of them as the CPU's high-speed memory pockets, allowing for lightning-fast access and manipulation of data. They play a crucial role in speeding up operations, making the CPU much more efficient. Computers operate on instructions, much like following a recipe. Each instruction tells the CPU what to do step by step. Instruction sequencing is like the order of operations in that recipe, ensuring that tasks are executed in the correct sequence to achieve the desired outcome. It's fascinating how a complex task can be broken down into a series of simple instructions that the CPU can understand and execute. It's like a perfectly choreographed dance, with each instruction guiding the CPU's moves. Finally, let's talk about different CPU architectures, RISC and CISC. RISC, or Reduced Instruction Set Computing, is like a minimalist friend who prefers a few versatile tools. They believe in simplicity and efficiency, using a smaller set of instructions that can be executed quickly. On the other hand, CISC, or Complex Instruction Set Computing, is like a tech enthusiast with a tool for every situation. They favor a broader, more specialized set of instructions, even if it means more complex hardware and potentially slower execution times. Thanks for watching. We hope this video helped you understand the basics of computer architecture and organization. It's amazing how these concepts underpin the technology we use every day, right? From the moment you hit that power button to the time you close your laptop, you're witnessing the intricate dance of bits and bytes, guided by the principles we've explored today. Don't forget to like, share, and subscribe for more informative content. We've got a lot more tech goodness coming your way.